Alright, today we're going to have a look at some further work with properties of vectors. So we've had a look at some of these in previous examples, but really going to hone in it today and have a specific lesson just on the properties of vectors. So first of all, does a point lie on a line? To determine whether a point lies on a line, we can check to see whether x, y, and z values, or plus z if needed, can be created using the same parameter of lambda. So let's parameterize this equation. So x is equal to minus 1 plus 3 lambda. Y was 3 plus 4 lambda. And z is going to be minus 2 lambda. Let's set this equation to be equal to minus 4. If we do that, we're going to get minus 3 on 2, I think. No, we're not. No, minus 1. So let's substitute that into each of these coordinates. So 3 plus 4 times minus 1 is minus 1. Let's write that. 3 plus 4 times minus 1 is minus 1. Good. Minus 2 times minus 1 is 0. An alternate way of doing that is to set this to be minus 1. If you solve that for lambda, you'll get lambda is minus 1. And set this to be 0, solve it again, you'll get lambda is minus 1. If you get the same lambda 3 times, then it lies on the line. Okay. The point of intersection. To find the point of intersection of two lines, we must use different parameters for the two lines. So if the lines are written with the same parameter, then change one of them to a different parameter. We then solve the equation simultaneously, needing only to find one result, and then substitute it into either original equation to find the point of intersection. Exactly the same we've done in Year 9 maths. So let's parameterize these and let's set the parameter to be t and s, nice and easy. So x is going to equal 2 minus t, y is equal to 3 plus 2t, and in the second one, x is equal to 6, let's go 3s, and y is equal to 9 plus s. Let's solve those. So 2 minus t is equal to 6 plus 3s, and 3 plus 2t is equal to 9 plus s. So here we've got 3 equations in 3 unknowns. If we do that, so we might times the top one by 2, so 4. Minus 2t equals 12 plus 6s. Call that equation 3. And then on the bottom, 3 plus 2t is equal to 9 plus s. Let's of course add these equations. 3, and that was equation 2. 3 plus 2 is equal to 7, is equal to 9 plus is 21, plus 7s. So what's that? 7 minus 21 is minus 14, divided by 7. S is equal to minus 2. And then of course you're going to get t is equal to I don't actually think we don't actually need to find t, because all we have to do is then substitute that into this equation here. So therefore the point xy is equal to 6 plus 3 times minus 2, which is, 0. And then 9 minus 2 is 7. Yeah, so we didn't actually need to find t because we didn't need it because we've already got one equation there. We've already got an equation for s that will give us x and y, and since they're intersecting at a singular point, it's going to be the same no matter if we found s or t. Okay. Converting between vector and Cartesian equations. Again, we've seen this scattered throughout the other exercises, but let's hone in on that just today. So for two-dimensional lines, we can convert from a vector to a Cartesian equation by finding the parametric equations and then solving simultaneously. Generally rearranging the equation for x to make the parameter the subject and then substituting into y is easier because it's much easier to graph things when the y is the subject, or at least we've learnt techniques to graph when the y is the subject, so let's keep using that. So rewrite the following vector equations in Cartesian form by first finding the expressions for x and y in terms of lambda. So x is equal to 1 plus 3 lambda, and y is equal to 2 minus 3 lambda. Let's make lambda the subject of the second one, or the first one. Lambda is equal to x minus 1 on 3. So therefore y is equal to 2 minus 3 lots of x minus 1, not 3. Now I just made a mistake there, and I was just about to say I would go from here straight to here, but maybe don't do that because you can see I just made a mistake. So y is equal to 2 minus 3 lots of x minus 1, which will give us y is equal to, no, I made another mistake. That 3 will cancel with that 3, so y is equal to minus x plus 3. God, just ignore me, I'm making way too many mistakes. Okay, part B. So we've got x is equal to minus 2 plus 4 lambda, and y is equal to 3 plus 2 lambda. So that, of course, would make lambda, let's hope I don't make any mistakes this time, lambda is equal to x plus 2 on 4, which means that y is going to be 3 plus 2 lots of x plus 2 on 4. The 2 and the 4 will cancel, and you're going to get y is equal to a half x plus 4, yeah. Okay. Alright, and that's it for today's lesson. Thank you.